Hey everybody, Darin here. So it's still winter here in Michigan, but it's a real sunny day and the lake ice is starting to melt, which means spring is right around the corner. Either way, it's still never too early to start thinking about summer. So it's time for me to finish up a project that I started late last year. I live on a no-wake lake, and what that means is that you can't have gas engines. So you can have paddle boats, anything that's got a trolling motor, but nothing that actually has a gasoline engine. So a few years ago, I was actually fortunate enough to be able to find this. Now this is actually a pontoon boat, but it's got a Mississippi River style paddle wheel to it. So it's man-powered, but it's the full-size pontoon boat experience, but with a paddle wheel. Now the good thing about it is that it's a movable platform. It can go all around the lake. The bad thing about it though is that on a really windy day, it becomes quite a bit of a wind catcher. So it's a bit of a sail. So last year I took an old trolling motor, basically cannibalized it, and attached it to the rudder, put some extra wires on it, and put the control module up where I could reach it, the pilot seat. Now that worked, but it wasn't really that safe or convenient. So before it's time to actually get out and start boating, I'm going to finish the project by designing and 3D printing a throttle body housing for the control module.
Last year I attached the motor to the rudder with some hose clamps and ran the wires to the pilot seat, but this year I want a throttle with a professional look. Even though these motors look somewhat large, when you get inside, it turns out to be a pretty small mechanism. In this video, we're going to detail each step of the development process. My goal is to create a professional-looking throttle housing and handle. I try to find inspiration wherever I can, and a Google search is always good for when my artistic side needs a kickstart. Now that I have a clear goal, it's time for SolidWorks. First, I modeled the switch. There's not a lot to show here, just a pair of calipers and a series of extrudes and chamfers. It may cost me a little time up front, but it provides me some necessary clarity when it comes to fit and clearance checks later. I quickly decide what really matters and focus on that. Besides the switch itself, I clearly need the wires. The connectors on the back hang out nearly an inch, so we need enough room to accommodate those and the minimum bend radius of the wires. Here I'm using 3D sketching to create sweep paths for the wires. Remember, there's no need for a sketch when the sweep's cross-section is circular. A few more minutes on the switch plate, and I'm ready to move on. A quick check-in to SolidWorks PDM, and my files are safe in the vault. Top-down design is where SolidWorks really shines. First, I'll roughen the position of the switch, and then I'm ready to mock up the housing. I find that inserting photos and sketch planes is a low-budget way to add some realism to the process. Now it's time to focus on the shape of the housing. For swoopy organic shapes, I typically rely on splines. I'm just going to roughen the shape, see where it takes me. SolidWorks has exceptional flexibility, which is great during the concept and development phase. Now mating the sketch and the assembly is more of a bottom-up approach, but the boat already exists, so I know the holes aren't going anywhere. Change is constant though. I originally envisioned modeling tabs on the housing, but let's move the holes to the interior for a cleaner look. I also assumed I'd be lofting this shape, but I really think a simple extrusion with some conical fillets will be sufficient. We can just hide that sketch in case something changes. Alright, that's a good start, but I still need the all-important handle. This is where I have to deal with a significant design constraint. Quick mock-up and I can start to flush this one out. Nothing tricky here, just sketching. Each speed is a 30-degree click on the switch, 5 forward speeds and 3 reverse. It's critical to orient the switch so I have clear movement to 240 degrees of rotation without interference. Let's make it just a touch shorter and flip the orientation, and things are looking better. In SolidWorks, we can make sure it's right the first time. There's still some interference, but I think I know how I'm going to address that. A little polish on the handle, and it's looking good. Now I can make my changes while still leaving room for the wires and switch. There, the movement's now clear and I don't see this getting drastically different, so I'm going to get the handle print started. I just thought of something to add. I don't want to modify the boat to run the wires. So I'm going to create a channel to cover the wires as they exit. A little more fine-tuning, and leveraging SolidWorks to reorder a few features. The housing's looking good. We have a place to conceal the wires. And the throws on the switch look good and don't collide with anything. The last design element is to create the mounting supports for the switch. Using a true top-down approach, I'll define the necessary geometry by referencing the switch model directly, ensuring a perfect fit. Let's add a couple extra supports to the sides. Alright, I think we're ready to make this thing real. Back to my trusty and highly utilized 3D printer. While I wait for the housing to print, I need to get back to the motor. For a cleaner look, I need to cut the shaft down. A Dremel with a cutoff wheel is the ticket, but I need to make sure I don't nick the wires inside. Not only do I need them, I need to extend them. I need several quality waterproof connections. I'm going to twist and solder and shrink wrap each of them. Adding some dielectric grease will keep these connections watertight. Silicone seals the shaft. And FlexLoom provides a clean look for the final wire bundle. The print is going well, so I've got some time to mount the motor and rudder and run the wires. Now, since the ice just melted, the water this time of year was super cold. I was able to determine the true length of the wires I needed with a mock-up in SolidWorks. Things are easy to execute when you plan properly, and it saves you from overspending on materials or being forced to run back to the hardware store. The 3D prints are done. We just have to remove the supports and then test the fit. I had little doubt, but it's still satisfying when things go together well. All I need to do now is connect the wires, reattach the boat panel, and mount the new throttle assembly. Everything looks great. A few zip ties and some electrical tape really clean up the installation.
So in a matter of just a few hours, with a little bit of imagination, nothing but SolidWorks and a 3D printer, we were able to go from concept to reality. So now it's trying to go ahead and see if this thing works. Come on, this is Michigan. You know the weather can change just like that. You ready, babe? All right, let's go.
Contact us at DASISolutions.com and we'll show you how to turn your ideas into reality.
Here. All right, great job, baby. Thanks a lot. Appreciate it.